Yay, math.
Yay, math!
Awesome. Okay. So today's warm here today is talking. Our data here is on patterning. Okay. So I tried to give you something that's a little bit fun, a little bit different. This one's called Sissa's Reward. This is an old legend on the side. So it said, according to an old Indian myth, Sissa ben Dahir was courtier for a king. Sissa worked very hard and invented a game which was played on a board similar to chess. The king decided to reward Sissa for his dedication and asked what he would like. Sissa thought carefully and then said, "I would like 1 grain of rice to be put on the first square of my board, 2 on the second square, 4 on the third square, 8 on the fourth, and so on." The king thought this was a silly request, but little did he know. Below is a chessboard with the first few. Right, natural here. Below is a chessboard with the first few squares of rice that Sissa asked for. I'm going to try and scroll down here. I don't know why that's not going. Okay, so it goes 1, 2, 4. This is the page you just won't scroll, it looks like. Ah, there we go. Nope. Okay, I'll just know you guys have the page in front of you. I don't know what's happening here. Does anyone know what's happening? Anyone else know what's happening here? I don't know what's happening here.
Zoom out.
Is it unzoomed? I don't know what's going on. Okay, you guys can see. So it says here, how many grains of rice will there be on the 8th square? What were some strategies you guys used for this? Luke, go ahead.
I do this straight table. I went to table and I just made a formula from that.
Yeah, okay. So what we did is, they're on the, this is April 5th, and this is 15th, sorry. It should be on the bottom of your page there somewhere. Okay, it should say square, and then rice, or something like that it says. Is that okay?
Yeah.
Okay, so on square 1 I have 1 grain of rice. On square 2 I have 2 grains of rice. On square 3 I have 4 grains of rice, and so on. Okay, and that should sort of be what it looks like, I hope. So it should be 128 grains of rice. And hopefully everyone got that. Okay. What was the pattern that we used there? Someone other than Luke here, sorry, somebody else, right. What was the pattern that we used?
You just double the initial.
Right, so we doubled it. Let's use some more math words other than double. What do we do math-wise? Multiplied by 2. Okay, now the reason I want that is because I want to make a formula out of this. All right, because if I were to ask you to do the 64th square, which I think they do next, okay, that would take a long time. And if you ever make a mistake in one place, there's going to be an error. So let's try and make an equation out of this. This I'm just going to call 1 times 2. That's how we got that, okay? So what I did for the 4th square, just times this by 2. So I'm going to call that 1 times 2 times 2. Okay. Then the next one I'm going to call 1 times 2 times 2 times 2. What's something I can simplify those? Because I don't like that. I want that simplified a little bit. How can I write 1 times 2 times 2? Just go ahead. Yeah, okay, so this is going to be basically just 2 to the power 3. This one's going to be then 2 to the power 2. What's the 8th square going to be then?
2 to the power 8.
Nope, close. 2 to the power 7, okay? So what we're going to say in general, whatever the square number you are going to do, it's going to be 1 less. Okay? And again, if you don't believe me, you can count by hand all the way, and I'm sure some people did. Okay, right? But once you get like to the 50th square, the number is enormous. Okay? So for this, they have the next part to ask, the 64th, I'm getting ahead of myself here. How many grains would you need altogether? So the 15th square is just going to be what? How do I figure out the calculate 15th square?
2 to the 14.
2 to the 14. Okay. You said it's 3 or 4?
Yeah, you have to add them all together.
Okay, well, we'll deal with that in a sec. We'll deal with that in a sec. So on the individual square, there's going to be, that'll be on the individual square. Now, somebody from the back of the crowd told me correctly I need the total. Okay, so I'm going to make another chart here to continue on my other chart. There's my square, there's my rice, there's my total. Okay, I'll do the first few. So square 1, I'll do the first 5 and hopefully get a pattern here. So we had 1, 2, 4, 8, 16. Here we have 1, here we have 3, here we have 7, here we have 15, here we have 31. Okay, can somebody try and get what that pattern would be? Because that's this one. How I got the right-hand column, I just did 15 plus 16 is 31, 7 plus 8 is 15, I just added one from there. I don't think of how you get that pattern, because there's another pattern going on here. Anyone see it? Yes, some of that? Yeah, good. So if you take a look, this would be, because this is like 4 minus 1, right? This is like 8 minus 1, this is like 16 minus 1, that's like 32 minus 1. That's sort of logic that you're using there for that, I think. And the same thing, this is going to be 2 minus 1. Okay, so everyone see sort of how that's looking there? So what I'm going to call this, 2 to the, I'm running out of room here. 2 to the 1 minus 1, 2 squared minus 1, 2 cubed minus 1, 2 to the 4 minus 1, 2 to the 5 minus 1. So on this 15 square, what's the total race going to be? Let's see the number going to be for the total on the 15 square. Somebody please play along here, other than Summer. Sorry, Summer, I know you got this. Somebody else here. What's the total going to be on the 15 square? Somebody please play along. Luke, go.
2 to the 15 minus 1.
2 to the 15 minus 1. Somebody please calculate that for me. You got it?
32,700.
Okay, that's quite a lot of rice. Okay. You can see how this is growing exponentially. We talked about exponential. Okay, right? So this is like shooting up like this in a hurry. What was the last question? They asked about the entire board? Yeah. Okay, so we try and get to the total on the 64th square altogether. How would you carry out the calculation for that? What's the answer going to be? Someone other than Luke and Liam and Summer. Somebody else, please. What's it going to be for the 64th square? What's the total going to be?
The total of rice used and the total on 64.
Total altogether. Total altogether on the board. You're right. Sorry, somebody else. Give me the equation, somebody. 2 to the
64 minus
2 to the 64 minus 1, which is a huge number.
1.8.
Go ahead.
1.8 times 0.4.
Yeah, not that times. Okay, what does times 10 to the 19 mean? Any science students in here? Go ahead.
Like the 6 zillion or whatever. Something
To the
like
6 zillion. I'm going to say it easier than that. It means there's going to be 19 zeros here. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 race. Okay, that's enormous. Okay, that's huge. Okay, and the end of the moral of the story says yes, and the people were happy, and the king was poor, and he was not happy with the story, like all fairy tales go. I tell students this every year, and it works. Okay, if you want to be rich, tell your parents tonight.
Buy rice?
No. Tell your parents tonight. Mr. Sadler says that I need to do more homework. I'm having a hard time. And Dad, I need motivation. How about tonight you give me $1 to do my homework, and then tomorrow I do my homework. You do 2, then 4, and 8, and I'll work for about a week, and then all of a sudden the deal won't work anymore. It's a penny if you want to go for that. Look at money, that'd be huge sometimes.
Isn't it like if you double, get a penny and then you double your money? Get a penny, so a penny, and then you double whatever you had every day, it would take how many days? Say 27 days, something like that. To get $1 million.
Yes, and that's basically what this. That's an exact example is this, right? Okay, so for what you said there, it's going to be then your starting value is 0.01 times 2 to the 27 minus 1, and that's what your number's going to be at. So you do 2 to the 20. Because this is sorry, if you guys didn't hear what happened here. Brad was telling a story that you start with the penny, you double it every day.
I don't know if that's right. Brad.
That's the 27. Well, what we're going to do is find the math here to see if it actually is there.
Yeah, it is.
What does that turn into?
$1,342,077.20.
And if you did 2 to the 26, it'd be half of that, right? It'd be 600,000 or 650,000. Right? That's some cool math. I like it anyway.
Cool math.
Okay, let's get into today's lesson. I'm going to pause the video, and thank you for playing along with that. Okay. This whole unit here is going to be on patterning. There will be, a lot of things open. Strong.